Potentiometer is a device to find out the EMF of a cell. Now, we have studied about the voltmeter. Using the voltmeter, we can find the potential difference between the two ends of a conductor. Okay? Two ends of a cell. We can find two ends of conductor potential difference. We can find. Here we have compared the EMF of the cell. This potentiometer is more sensitive when compared to the voltmeter. Why? Why do you prefer the potentiometer over the voltmeter? Here because potentiometer number one is more sensitive and more accurate when compared to the voltmeter. We find out the potential difference using the voltmeter, but here we can get the EMF, electromotive force of a cell using the potentiometer. That is the difference here. That is the reason it is more sensitive. Now, before going for the potentiometer, let us see what is potential gradient. Now, in this is a length of the wire we have taken. In this length of the wire, capital L. Capital L is length of the wire. It can be, this potentiometer wire can be 4 meter, 8 meter, like 10 meter, it can be there, the length of the wire. For our convenience, we have taken on one length of the wire. This wire is made up of conductor, again, or manganese. Potentiometer wire is made up of an alloy. It is made up of an alloy. Now, we will see the actual potential, how it will be there. Before that, let me see what is the potential gradient we will find out. This wire is, resistance wire is connected to a cell, to a battery of EMF E. Now, let us take EMF E, it has some internal resistance also will be having. I will write here as the internal resistance small r between the cell. That is high. Now, this is what is the resistance in the circuit. This is 100 centimeter length of wire. Let us take L is the length of the wire. Now, in this one, what is the potential difference across this length of the wire? V is equal to how much? And what is that will be the same across this one. Potential difference across the cell will be equal to the potential difference across the length of the wire. Okay. Now, it has internal resistance R. What I can write here? What is the current passing through the circuit? I is equal to E by resistance of the wire. Let us take capital R plus small r. This is the resistance of the internal resistance of the circuit. That is the total resistance present in the circuit. Okay. This I can write to some x into r, the resistance per unit length into the total length we are going to get. This total resistance of the length of the wire. Suppose small x is the resistance per unit length. Per unit length. Then total length is x. L length is there. This L into x. This is equal, let us take r. That I can take like that. That is length of total length of the wire into the x. That is resistance per unit length. 1 centimeter wire, itna resistance. The total length L into Lx is equal to r. This is the current in the circuit. I is equal to E by r plus r. That is the direction of the current is along the direction. Now, potential difference. What is the potential difference across this resistor? That is across the resistor. V is equal to I by r. V is equal to IR. Now, what we want is what is the potential? This is suppose V potential is across this length of the wire. For 1 unit, what is the potential? For whole length L, for L length, potential difference is equal to D. For 1 unit length, it is how much? This is equal to V by L. This potential per unit length is known as the potential gradient. Potential per unit length is known as the potential gradient. How to find out this potential gradient? Suppose let us take this is a 4 meter length of the wire. It is a 4 meter length of the wire. Means 4 meter is equal to 400 centimeter is equal to 4000 millimeter. The length of the wire L is equal to capital L is equal to this one. For the separation between the two lines will be equal to 1 millimeter. For 1 millimeter, for 4000 millimeter, this V is the potential. For 1 millimeter, kitna? Now, suppose if I give here, suppose 10 volt I give for this cell. If I give 10 volt, then potential gradient is equal to how much it becomes? Potential gradient is equal to K is equal to V by L. V is equal to kitna? 10 volt divided by the 4000. Let us take assume that internal resistance is 0, negligible. Then what happens? This is equal to 1/400 is equal to 0.0025. This is the potential. This is the potential gradient if
volts per meter.
Potential gradient volt per millimeter. Volt per millimeter. Means if 1 millimeter you move, there is a potential drop of 0.0025 potential drop is there. Now we have this much 4 meter length of wire is there across this one. Now at this point, suppose it is 10 volt, this will be at 0 volt. 10 to 0. When potential difference is there, only electric current will pass. If it is 10 volt difference here it is there, then it is having a 0 volt. Then each millimeter when you travel, 0.025 potential drop will occur. Suppose if I go for 10 centimeter, how much? 100 centimeter, how much we can get? That is into 100. Suppose 100 centimeter length of wire, if I go, what is the potential drop? 100 into K. K is equal to 0.0025 into 100, which is equal to 0.25 to 0.25. 100 is equal to 0.0025. చాలా తక్కువ వస్తుంది మిల్లీమీటర్ కదా దిస్ ఇస్ మిల్లీమీటర్స్ పర్ మిల్లీమీటర్ 0.0 దిస్ 100 మిల్లీమీటర్ 100 సెంటీమీటర్ టు 1000 మిల్లీమీటర్ 0.25 పొటెన్షియల్ వోల్ట్ పర్ మీటర్ మార్చుకోవాలి 100 centimeters. 1000 millimeter రాసింది కదా మిల్లీమీటర్ వోల్ట్ పర్ మిల్లీమీటర్ కదా
వోల్ట్ పర్ మిల్లీమీటర్ కాబట్టి 1000 centimeters.
1000 millimeters.
So this is volts per millimeter.
Millimeter. K is equal. It's not K. Sorry. It's not a potential. 0.025 volt per millimeter. Potential suppose V AC, let us say A, this is C, up to point C.
is equal to that into
V AC is equal to 0.0025 into
1000 millimeters.
Volt, millimeter volt. What the volts was that? Potential drop.
Cancel.
Millimeter
Millimeter
cancel. Millimeter will cancel. That is volt will be left over. Then how many zeros it will go?
5 to 5.
Huh?
5 to 5 volts.
Volts now only. Volts now 2.5. 3 zeros will go now. 1, 2, 3, 3 zero, 2.5 volt. 100 centimeter, 2.5. 400 centimeter, 10 volts. Like that. And the confusing of people are also practice. Okay, na? That is potential drop from 100 centimeters 2.5 volt. This is not the potential gradient. If I go along this one, that was potential at this point is 10 volt. Potential at this point is 0. If I going on decreasing here, it becomes 0. This is 10 volt. 10 volt. Here, this becomes 0 volt. The potential difference becomes that is 0. 10 to 0. It is decreasing. as with length L is increasing to 400 meter length, 400 centimeter length, it becomes 0 at this point. Potential drop will be 0. Like that, we will be knowing now. Now that is this is the what we know. Potential, this is known as the potential gradient. Once we know the potential gradient, we can find out the EMF of the cell like that. Now let us see. This is the primary circuit. Now let us go for the secondary circuit. This one, same thing. Here is the one. Compare the EMF.
Increasing or decreasing?
Here, what is it? Decreasing. 10 to 0.
First 10 volts.
First 10 volts. Positive గా తెలుసుకున్నాం. ఇది పాజిటివ్ అంటే పాజిటివ్. ఇప్పుడు చదువుతాం. Positive terminal is connected. This is the direction of the current. Here this is source EMF. This is the potentiometer wire. For convenience, we have taken only one wire, but it can be of 4 wire, 8 wire, 10 wire, depending on the length of the wire we are going to have. This is the potentiometer wire. This is connected. That is one positive terminal is connected to one end of the potentiometer. Another end of the potentiometer wire is connected to the key to the rheostat. That is to change the current in the circuit. Connected to the negative. This is the primary circuit. In this one, what we have seen potential gradient K is equal to, we have seen K is equal to V by L, total length of the wire. Now, let us connect to one cell E1 by E1 and to the K1 and K2. There are two cases are there. Now, when you move the galvanometer along this wire, there will be two-sided deflection. There is two-sided deflection, there will pass the current to the two sides. Here, important thing here, positive should be connected to the positive of the cell E1, and negative is connected. Means there only circuit current will pass. In the absence of this, when the keys are open, both open, this is the direction of the current is passing. This is the direction of the current is passing. When in the presence of this closed swing, what is happening? There is current here. According to the Kirchhoff's laws, again there is current passing here. Passing from this direction, from the cell E1 in this direction. Suppose this is I1, this is I2. It can be I1 minus I2 or I1 plus I2 depending on the polarity of the cell. That is, suppose at this junction entering I1 and I2 are entering, and I3 will be passing through. I3 will be this passing. Now, when the circuit is closed, here what is happening? It is passing like this, and there is one more current is passing along this, like the circuit is being closed. Now, when you move the galvanometer jockey, at one point, let us say point L1, at the point L1, it is showing zero deflection of the galvanometer. Zero deflection of the galvanometer is the current passing through the cell in this direction is zero. Only current is passing along. That is, through this one it is zero. When it becomes zero, if the EMF of this cell is equal to the potential difference of this cell, when both are equal, it becomes zero. Now, how can you say, sir, that is possible? How it becomes zero? Here is one more example I will give you here. How it becomes zero? Here is a cell. Battery. Here is another battery. Both are connected. Here is a galvanometer to show the presence of the current. The current due to this one, this is the direction. It will flow like this. Current due to this is moving the opposite direction. That is anti-clockwise. One is clockwise, this is anti-clockwise direction. Let us take E1, E2. E1 and E2. Suppose when this is open, when E1 and E2, when the deflection shows, when sometimes the deflection will be in this direction, if E1 is greater than E2, if E2 is greater than the E2, it will flow like it will be, deflection will be other side. Suppose if E1 is greater than the E2, there is deflection. What will be the direction of the current? It will be flowing in this direction. If U2 is greater than the E2 is greater than the E1, then the current direction is clockwise. Then it will be flowing in this direction. Then deflection will be opposite side. When suppose let us take this is 10 volt, this is 12 volts. Then what happens? Current direction is clockwise direction. When you change this voltage, you increase this one. 10 volt, 11 volt, then what happens? 11 volts, then 12 volts, let us see. When both are 0, then the deflection is 0. Because both the currents are the opposite direction. Deflection is 0. Therefore, positive of this cell is connected to the positive of this cell. If negative current, what happens? There will be current flow 0, galvanometer 0, deflection 0, you will not get. This is happens when both the EMFs are equal. Both the EMFs are equal. Now, this is the potential difference across this one. Potential difference across this one V1 is equal to the EMF of this cell. Then that is equal to that is EMF of the cell is equal to the potential difference, then it shows the 0 deflection.
So E is greater than E1.
Always E1, E should be greater than the E1, that is to current to flow. That is the reason. Now here what happens? V1 K is equal to V by N we got. Now what is the potential difference across this one? V1 is equal to, or E1 is equal to K into L1. Potential per unit, potential gradient potential per unit length into the total length of the wire, where we got the potential. Now potential difference across this is equal to the EMF is there, it is possibility is there that it shows the 0 deflection, not this and this. This will not cannot be become equal. If it is equal, there will not be any current in the circuit. Okay. Now E1 is equal. Similarly, you open the circuit, then close the second K2, then E2 is equal to K into L2. Then E1 by E2 is equal to K by L1 by L2 is equal to K by L1 by L2. E2 is equal to E1 by L2 by L1. By knowing the L1 and L2, we can find out the compare the EMF of cells. In this one, if one is known cell, if E1 is equal to 1.5 volt, then we can find that E2 is equal to, we can find by knowing the L1 and L2. For this one, we have the small demonstration on the potentiometer. We compare the EMF of two cells, first experiment, and second experiment we have to find the internal resistance of the cell. In the case of the internal resistance of the cell, hydrogen, here same up to this we know, and this also we know, shows the galvanometer deflection. Now when it shows the galvanometer deflection, that potential difference across this one will be equal to the EMF of the cell, 0 deflection source. Then by adding one resistance parts parallel to this cell, what is happening now? The current is passing in this direction. A series. Now current is passing in this direction. There is current in this direction. With that one, the balancing point again changes. Now we have the second for balancing point, V1 is equal to K into L2.
This is terminal potential. Terminal potential.
First one is E1 into, first one we got E1 is equal to E1 is equal to K into L1, first without battery. By connecting this, we get the potential difference across this battery. Potential difference that will be equal to the potential difference of this length of the wire. First we got EMF, now we got by connecting the, because of the resistance box we are getting the potential difference across this cell. That is equal to V1 is equal to K into L2. Right? K into L2. E1 by V1 is equal to K, we get the L1 by L2. We get E1 by L2. This is equal to, what is the current passing through this one is equal to I1 is equal to E1 by R plus R. V1 is equal to I1 into R. We can find out the internal resistance. This is the current in this, what is the current in this one, right? Current passing through the circuit is I1 is equal to E1 by internal resistance cell plus capital R. Then V1 potential difference equals I1 into R. I1 into this R. E1 by R plus R into capital R. Then making equal these two. R plus R by R. E1 substituting for E1. E1 by R plus R into R. V1 is equal to
E1 is equal to KL1. E1 is equal to KL1.
KL2. V1 is equal to KL1. V2 is equal to KL2. V1. V1 is equal to KL2. That's okay. E1 by V1 is equal to E1 by V1 is equal to K into L1 by L2 KL2, which is cancel, which is equal to E1 by V1. E1 by V1. V1 is equal to E1 by E1 into R by R plus R. Okay. E1 get cancelled. Then it will go to the numerator. E1 by V1 is equal to R plus R divided by R. Okay, which is equal to L1 by L2. Then I can add this 1 plus R by capital R is equal to L1 by L2. R by R is equal to L1 by L2 minus small r is equal to L1 by L2 minus JNV over. Got it. That is internal rule we can find. Here, what we can, this is the I1 item. I1 and E1. This is the current passing in this circuit. I1 is equal to E1 by R is R. Internal resistance of the cell plus capital R. We are finding the internal resistance of this cell. This cell the internal resistance we are finding. Therefore, R plus capital R. Then V1 is equal potential difference across this one. V1 is equal to I1 into R. The I1 is equal to what? We have to substitute V1 by R plus R into R. Potential difference across this resistor is equal to potential difference across the EMF. That is equal to I1 R. I1 is equal to E by R plus R by R. E1 is equal to KL2. E1 by KL2 will cancel. E1 by substitute for the E1. P1. E1 is equal to E1 R plus R. E1 get cancel. R plus R. This is regarding internal resistance of a cell. Then now let us play. Demo number is ready here. It is end the time in half an hour, is huh?
20 minutes.
12:30.
23 minutes.
20 minutes. Huh?
20 minutes is about 10 minutes. Time
Huh?
40 minutes. 40 minutes తర్వాత break. అది 10 minutes break. 15 minutes. 20 minutes. 70 minutes. 70 minutes వరకు అయిపోతుంది. బ్రేక్ వస్తుంది మినిమం 20 minutes.
ఈ ఎక్స్ప్రెస్ ఇదే కదా
డైరెక్ట్ సార్ డైరెక్ట్ 2 పాయింట్స్ తీసుకోవడం అంతే. డైరెక్ట్ 2 రీడింగ్స్ 247. ఇది కొద్దిగా దాన్ని సర్క్యూట్ ఎక్స్ప్లెయిన్ చేసేసి ఇది ఇచ్చేసి జస్ట్ డైరెక్ట్ పాయింట్స్
గట్ టైం గట్ డౌన్
some time next questions time ఉండకపోవచ్చు. టైం
సాల్వ్ చేసాము. Calculate the value of currents in the arms AB, BD, AD and BD. AB, AD and BD.
like balance panel.
The balance current is I2 becomes 0.
First equivalent resistance.
Equivalent resistance is we can write this way. Huh?
Zero resistance. X.
This is
X.
X. This is 12 plus 6 is 18 ohm.
Yes, x by 2 is equal to x by 6. Direct question distance. 6 by 2 is equal to
6 by 12. Divided is 6 by 12. Is equal to 6 by 6.
x by 2 is
X is equal to.
series parallel.
The resultant is I not one.
That equation will be
This is parallel.
एक दिन के बाद ना नहीं वो हमने उस दिन हुआ था ना 20 सेकेंड तो उसका आपका पड़ेगा तो पेशेंट करवाना
What can current
मुझे इसमें करने के लिए मैंने देखा लेकिन नहीं मिला अगर आपके पास लिंक है तो सेंड
ampere current is coming here. This is what
It has 6 ohms or 2 amps.
6 ohms.
Device.
जैसे जैसे
So current I1 and I1
అది కనుక్కోవాలి అది ఇక్కడ ఫార్ములా I is equal to I.
एक दिन बाद
there is series AC potential drops to 12 volts. 12 volts what is 12 equal to
And C.
12 equal to 6I1 plus 12I1. 12 equal to 6I1 plus 12I1. 89. Because they are series same current.
The same current passing.
12 equal to
6 applying the Kirchhoff's law. Second rule we have to apply. Apply the Kirchhoff's second rule. Like this we can say. Second rule we will make it to 6 in same direction.
minus 6I1
Minus 6I1
minus 12I1
minus 12I1 negative passing. Negative passing. This is AB. Similarly, AD. AD is I minus I1. I is equal to 2 ampere. I minus I1. 2 minus 4 by. It will be another negative 0.
By 2 by k again 2 amperes. Your problem gone.
Okay, that's it. Now, you have any questions?
No, you may.
Questions? Right. రాయాలి కిర్చాఫ్ మళ్ళీ ఒకసారి రాయాలి
ఆబ్జెక్ట్స్ రాయండి దీని తర్వాత బాగుంది. ఇక్కడ లేదు, లేదు. ఓకే ఐడియా. Objectives. Plus Prestige. Pops, double F.
Huh?
Chops,
Huh?
double F.
Double F.